So there's a couple things I really want to go over. Really excited. It's tough because it took me a lot of work, and I'm not at all like an amateur. If you saw all my videos in Unreal, I mean, you saw all my videos in Unity, you saw my videos in Blender. Not even close to an amateur. There's all these people who are like, well, I've done this for 14 years, I've done this for 10 years, I've done this for X amount of years, and blah blah. That's always been the case with me, where somebody says I've always done this for X amount of years, and I've just been like, I picked it up in 2 weeks, or I picked it up in a month. I never let those people get me down. They're not my daddy. They're not your daddy. I'm not your daddy. And somebody's like, well, if you want to get ahead, you have to follow 14 years experience above ice. No, if you want to get ahead, you follow what's proven. That's the Scrum method. That's what businesses follow. There's people with 2 years experience who build big ass. That's what Beta was. But fifth largest advertisement company in the world, built in less than 2 years with no experience. So when people say I have this much experience, yeah, congratulations. You have that much experience to do what? Get hired. Not to build a company, to get hired. That's the only thing that experience is good for. Knowledge is power. Experience is wisdom. And proof of knowledge. So, I can go here, I can press play, and you'll see my mouse drag across the screen, and every time I touch one of these screen objects, that's the cat. You're like, well, your game looks like shit. Congratulations. You don't understand me or the game because this is just based on functionality. This is just base functionality. If you want a beautiful thing to look at, here you go. Oceans and all that other stuff. Fucking noise islands and all that other stuff. I can't even get into the details of that. I'm under contract, obligated not to even talk about this at all. And the only reason I'm showing it to you is because I'm going to change it anyways. So I'm allowed to show that to you. Okay? Node. Just to show you what these are. If I press play, it's like, what the fuck is that? Well, this is for a touchscreen game. And I remember showing you that my buttons move based on the screen resolution. That's true. That's simple. That's easy. Buttons move on screen resolution. And my touchscreen controls are actually much larger than the resolution. So every device can work with it. That's what I did. Because I'm using 3D. But I need 2D controls. So that's fine. So I don't even need to show you that anymore. I'll just show you the script. The script is fairly simple. I can't go into too much details with this. And for now I have to leave it unlisted. Under contract to. But and there's a lot more cooler stuff coming, trust me. This is the bare minimum I can share, is what I got here. What I got here is the bare bones minimum what I can share, and one of the things I'm going to share in this video is my algorithm. And how you can build your own algorithm. And I can't even share that in its entirety. But I can share the math and the method. So, basically all I did was I set my stuff up with children, and lots of people are like, well, not lots of people, some people are like, you don't want to use children. And the truth of the matter is, it depends on what kind of game you're building, because if you're building a certain kind of game, using children is very advantageous. In this case, using children is the only and best format to do, because what do I have here? 800 touchscreen button children, and somebody could be like, well, I could get where touch pressed or whatnot. Yeah, you could, but could you narrow it down? I can get mouse position. Everybody can do that. But if button is pressed, this means that It only cares about when it's pressed, so it's not going to run 800 fucking times. That's why I kept it small. If the button's true, then I care about that interaction. I care about where my 2D cursor goes, and it's not this mouse cursor. It's a 2D cursor I built for the game, and a 3D cursor. It's called a projected cursor. And I care about those two things because those two things give me spots of distance and relativity, and they give me placement spots, location spots. Now, I don't care about just the intersections. I care about distance and all that other stuff in 3D space. So you can go if button press is true, if intersection not empty, var position intersection dot position, and this normally would be based on a mouse position, but instead I based it on the touchscreen button control pad position, which is exactly the same as a mouse position, or your position of your thumb would be comparably. And that would be ray origin dot camera project ray origin. That touch position is my touch button's position, which is right here. Touch button position equals position plus 32, so that it's kind of in the center of the button. Ray target equals ray, sorry for the background noise, ray origin plus command camera. That's just a variable I named it. Spatial node. No, the command cam. Yeah, that's the camera. Ray normal, and then touch position again times 1,000. That's copied. Not even gonna lie about that one. Then I get the world space. Then I get the intersection ray, or intersection equals space state intersection ray, and you use those two variables that you just made. After that's done, you got the intersection position. Projected cursor translation equals vector 3 position x position y position z, which is position equals intersection position. So that's how you get your x, y, z for your 3D cursor. For your 2D cursor, rect position equals position. Very simple. And then button press equals false. That was really easy line of code. I can't even explain the rest of this. But now basically a touchscreen works like a computer. That was the whole purpose of that. Simple code, 800 fucking children that do that. Alright, so now I have my units class. Not even going to get into that. I have the algorithms for my units. And what is the purpose of the algorithm? And it might sound simple, but it is to select things to a captain and assign them, and then take a different captain and assign other units to the new captain, and that's all that does. But it doesn't parent them, and it doesn't make them a child of that captain. They can still move independently. And if I have another button rearrange, whatever, it restarts that whole process. And in fact, it funnels them in one by one. So this is the algorithm I'm nervous about sharing because it took me a while to build. So basically, the algorithm, I can't even get into high details here. But I go through. This is tough. Okay, so basically I want to get the children of all these units. So I get the child count of all the units. That's my max count. Then I start with the count 0 and go through the list all the way up to my max count and end it. And then I make, if that 0 equals the max count, I restart it. And then, so I can constantly read whether these units are selected or unselected. And I do the same thing for my captains. And then the last funnel test, if target captain has the activated material, if unit has the activated material, unit get child surface material is assigned unit material. That way I can do a reassign if moved equals false, and then I go down where the child is supposed to be based on a scale variable. which it could be any variable, but I need a number.